Yeah. Hello everyone. Welcome to today's class. Today we're going to be looking at design patterns and architecture. So I don't know how long or short this class is going to be, but I'll try as much as possible to, you know, keep it very, very simple and while still trying to pass the message I'm trying to pass. Uh, I hope I'll be able to keep it very, very simple, anyways, because for me, I like to explain in a way that I'm sure you would understand or you'll be able to like at least see the picture from. So, design patterns, design architecture, design principles. I know we talked about some design principles in the last class where we talked about solid. Yeah, but in this one, we're going to be talking about patterns, right, and architectures. So, what patterns are, what architectures are, some types of patterns that we have, and some architectures, majorly. So, yeah, baseline definition. What are patterns, right? So, patterns are more like, a reusable solution to common problem as a developer. We're going to get into that in a bit, right? So more like, they provide this common vocabulary for developers to, discuss a design in software. So I know that based on my, small research for this class, right? It was first popularized, right, by a book called Design Patterns. If you want to check it out, Design Patterns, Elements of reusable object-oriented software. I don't know where you can get that. You can buy that, or it should be available for free. To be honest, just search on the internet for this for the PDF version. I can also do the check. But yeah, it was written by, for I don't know if they're software engineers, but they definitely are software engineers, right? It was written by four guys, and they are collectively known as Gang of Four. So maybe sometimes you might have heard of, Gang of Four patterns, blah blah. Yeah, they were the one that kind of like came up with the concept of design patterns, right? So the idea is to, offer like some tested solution to recurring problems. So let's say there's a certain problem, what is the best way we can solve this, right? Um, let's say, okay, we can use a simple class as an example. We have a class called random. I have no idea what to name the class. You have a class, right? In order for you to access this class, it's very, very easy for you to, come here and just random, random, and random. Yeah. And then you can do whatever you want to do with this class, right? And if you have another method or you have another class, you can call the same class in that method. But let's say you want, you know, a singular source of truth, right? You don't want you want this class variable to remain the same, you want the functions to remain the same. That's where a design pattern called Singleton comes in, right? So as you can see, it's more like, a solution to recurring problems. So people realize that, oh yeah, um, we have this problem where, we have to always recreate different instance of class, right? How do we solve this? How do we solve this problem? And they offer this tested solution for it, and yeah. So anyways, so it allows you to, reuse code and also be flexible. Yeah, majorly that's what a design pattern is. So design pattern in that itself kind of like creates this crucial, this maintainable and scalable uh code base, right? It kind of like plays a very, very big role in creating efficient and maintainable code base, to be honest. And we're going to see in a bit, because some of these things you already use them and you might not just know. Yeah, that is design pattern. So what are software architectures? What's a software architectures? Let me just go ahead and just clear this. So software architectures are kind of like, a high level structure of a software system. So it's more like a blueprint that defines how different components would look like, where your UI should go, where services should go, the motive of the design. Do you want it to be very, very testable? Do you want your system to be tightly coupled together? The interaction between components of your system. So components of your system refers to. So I'm trying as much as possible not to complicate things. They refer to what makes up your system. It could be your UI, it could be your logic, it could be any other thing, right? What makes up your system, your software system. Yeah, so yeah, there are like four key structure or key aspect of a software architecture. So we have the system structure. We have the system structure. We have component relationships, and then we have properties, and then we have design decisions. So we have system, structure. So this is how the system is divided into like components, right? Is uh, is it like a business logic component? Where how do we? Yeah, I'm sharing my screen. Please, can anyone confirm? Can everyone confirm you can see my screen? Um,
I can see your screen.
okay. So most likely your network. Yeah, so back to this, right? So system structure, component relationship, properties, and design decision. So system structure, like I mentioned, is how the system is divided into components, right? So is it your business logic component? Is it your UI component, right? And yeah, how these are divided, how you want to structure them. Then component relationship is how your components interact with each other, right? So how does your UI component interact with your business logic component, right? Do you want an intermediary? Depends on how you want to design your system, right? Or your architect your system. And then we have the properties. So the reason or the priority of your system of your architecture, the priority of your architecture. So there are some architectures that you want to you want speed, you want to prioritize speed over anything. And then the way to achieve that is have maybe tightly coupled software. So in the sense that your system is kind of like your components are coupled together in a way that enhances speed, right? And if you're looking at scalability, if you're looking at maintainability, right, you might want to reduce coupling um, for a little bit, or depends on the reasons for your decision, right? And if it's for security, also you can design your system in a way that enhances security. Right. If it's also for performance, like I mentioned, of speed, right? Definitely, you might want to, oh yeah, I want a very, very tightly coupled software, or I want an uncoupled software. Depends, right? So this is what your properties means, right? So you have to be able to tell what your software architecture does, or the reason for your software architecture, what you're prioritizing over another. If you're prioritizing security, it's just very, very easy. How I tend to lay my home down is we start, what are we prioritizing in this? Are we prioritizing security? Fine, right? Security. And then you just kind of like set this hierarchy. Then maybe performance can come in. Performance can come in, and then you can say, okay, fine, maintainability, maintainability. How maintainable if you want a scalable software, right? So you just, you know, you kind of like, create this hierarchy. Your security is priority. So in whatever decision we're making sure security cannot be compromised for, right? So you are making sure that there is no how you would compromise, no matter, let's say performance, let's say it's going to hinder performance in a way, you're prioritizing security using your architecture. So that's kind of like what properties of your architecture mean, right? So also design decisions, right? The decision behind, like I mentioned, so these are what will allow you to, the properties would allow you to make decisions, right? So, in the context of Flutter and that, right, architectural decision might also involve, choosing state management solution, deciding how, your project structure, or how patterns, or whatever patterns you want to use for data flow, how data flows into your application. It could be, if you want a unilateral data flow, that means just your data is coming from just one source, right? If you want a bilateral, just splitting your system design into two sources, right? If you want multilateral data flow, right, you can also like have that. So another thing is relationships between design patterns and architecture. So from what I've said about design patterns, and some things I've said about architecture, right? It's very, very easy to like say, oh yeah, there are some relationship, there are some related concepts, right? It's kind of like, whether we like it or not, we can say, oh, it's a pattern, right? But they have for different scope, right? So for instance, now when we talk about the scope of design pattern, right, the scope of design pattern is more tactical, and is focused on specific component interaction, right? So it's not how your full system interacts with each other. It's much more focused on specific component interaction. And yeah, architecture on its own is considers how the entire system interacts with each other. And also, for when it comes to granularity, also design pattern is much more granular, and fine-grained solution to common problems, while architecture deals with, like, cores, something bigger, um, core structure, and organization of your full system. So for design pattern also, right, in an application, multiple design patterns can be used in an application, in your full software application, or your full software um, app, right? But for architecture, right? Yeah, you would just want to settle for a single architectural style, right? So, oh, fine, I'm using MVC architecture, model view controller. You don't want to use model view controller for one feature, and then you're using another architecture for another feature, right? And yeah, so that's one thing you might want to use. But in the when it comes to design pattern, you can use observer pattern somewhere and then use factory pattern for creating models, right? And then use singleton for something else, right? So yeah, I hope you guys are seeing kind of like the picture between design patterns and software architecture. So another one is like the purpose of design patterns. So design patterns are aimed at solving specific problems, right? They're aimed at solving specific problems, while architecture aims to, kind of like fulfill the broader and, operational how your whole system operates in general. It kind of like, kind of like fulfills the requirement of that system. So it's more like, on the broader level, design pattern just solves like a single problem, a very, very simple problem. Yeah, so while working is very, very great to understand both patterns and architectures in Flutter and that, right? So yeah, so majorly that is kind of like a baseline introduction of what I feel design patterns are and what architectures also are, right? I don't know if I've been able to like, so if I've been able to talk about this and maybe there's something confusing that you don't understand. For now, you can ask question before I kind of like move on to the different design patterns that we have, right? So, does anyone have any question? Hello, does anyone have any question?
Yeah, I don't have any question.
Okay. I'll just give it like a minute and then we can just continue. So, if you can just like, look through, some of the things I've said, and if you have a question, you can just ask. Sure. All right. All right, then in that case, if there is no like question, we can just move for it. So let's talk about some types of design patterns in not necessarily in that in software engineering, right? But yeah, we're going to be using the context of that. So yeah. So we have creational pattern, we have structural pattern, and we have behavioral pattern, right? Like I highlighted here. And these patterns, right? They kind of like they kind of like you can already tell what they do based off their name, right? Creational pattern deals with creation, right? Creation mechanism in that it could be model creation or something around that. We have a structural pattern that also deals with structural. It deals with structural parts of your design pattern, right? And then we have behavior that also deals with behavioral, uh, the behavior of the way you can, structure your code to maybe perform a particular behavior or something around that. But we'll get into that. I don't want to go into details right now. So we'll start with creational and then we come into structural and behavioral. So you guys will understand what this means. So a lot of the times, right, a lot of these things, you guys already use it. The thing is, the only problem here is maybe because of the definition. That's why it might sound tricky, but yeah, once we get into it, you would understand. So the very first part of so creational patterns, right, kind of like deal with object creation mechanisms, right? So trying to create objects in a way that suits a particular situation or something. So yeah, we have um singleton pattern, right? So whether you like it or not, I am sure no one here is new to singleton pattern. Right. So the singleton pattern, which I mentioned earlier, right, when I was talking and I was trying to give like an example when it comes to design pattern, right? So the let me just come down here. So singleton pattern. I don't know how you pronounce it. Uh, uh, is that a question? Okay, singleton pattern. Singleton pattern, kind of like ensures that a class has only one instance to it. So ensures a class has only one instance to it. Right. So in that you can implement it with static field and factory constructor, right? Something around that. So yeah, in that we can implement it with trying to think of an example. Ensure a class has only one instance to it. In that implement with factory constructor with factory and static field. Okay, so let's say we have like a shared preference class. I think that's the best example I can find here. So let's do this. So folder, call this creational patterns. Call this creational patterns, and the very first one is singleton or dirt. So we can have a class called singlets. Okay, this is just to demonstrate you know singleton. So it doesn't make sense to start naming the class singleton. So what I can do is I can imitate a shared preference class. I know we have a shared preference manager, shared preference, shared preference manager. Um, so we can have this, and then uh, we can have shared preference. I hope this picture I'm trying to paint would work. But yeah, we can have shared preferences. We have shared preferences. So we can put the example. This is what we can put the example of, a singleton class in the shared preferences manager. So say we have what's the name? We can have a static shared preferences manager, and then which can be the instance of this class, right? Static. So the reason for static is so to access the instance, we might not need to. The reason for static is because the variable itself is static, right? Yeah, and also to access the instance without needing to create a class, but we'll get there. So let's try this. Static shared preference that we highlighted here, and then we can call this preferences. And then let's say initialize we have like an initialize method. This is me just trying to use an example, a shared preference example that from this project, but I'm not sure. But it will work anyways. It will work. So init, first I have an idea in my head, or maybe I would have just used something much more simpler. The preference equals to um, so same server. Yeah. Or maybe I should have just added the shared preference package instead of trying to mimic it. So this is a future void asynchronous await thing await shared preference dot static place. Let's get instance. The preference, let's get instance. There. Okay, so I hope this works. Okay, so we can just do it. Make it and make this late. So it's just going to try an error if this has not been initialized. So you have to always call the init method. So what we can do is use a factory to create an instance of this. So shared preference manager. So if instance, let's take this off, right, and make it null instead, so that if instance equals to null, right, instance dot equals to get preference manager. So we can create a private constructor to represent this. So shared preference manager. I'll explain everything I'm doing in a bit. Trying to get my idea right. Yeah, trying to get my idea right. So shared preference manager that's on the screen, and just leave it self. And leave it. But if you want to give it a name, we can call it internal. I know you might have seen this in multiple code bases. We can just call this internal. Or there's another name I use also. So I don't know why did this dude change my code for me. This is correct, but this is not what I'm trying to do. If instance equals to null, if instance equals to null, else return um, instance. It will still work. Oh yeah, actually I could have just returned it like this. So yeah, something like this works. So we can just have like a getter. Can just have a getter that gets the right to leave this here. So we can have a getter here. Shared preference manager gets instance and instance. Oh yeah, it's null. It's null. It's null. It's null. Should we make this just nullable? Anyways, so this is what a singleton class would look like, right? So there's only one point of access. So let's say you come in here, you have a void main, and then you try to create a shared preference manager, right? You try to create a shared preferences manager, and then you say shared preferences manager equals to shared preferences manager, right? Instead of having to do this, so instead of having to do this, right? Instead of having to like always create an instance, you just need an instance of you just need an instance of shared preferences manager to perform whatever operation you want to perform, right? So instead of creating new instance every time and then you need to track or you need to track this or maybe you have to always inject this, right? It's much more easier for you to just always access the instance this way. Yeah, this could be static. It's much more easier for you to always access the instance of this class this way, right? It's much more easier for you to always access it this way. If there's any variable that is being stored, say you want to use this preferences variable, right? When you create a new instance of a class, it doesn't take into consideration of maybe previous values that has been set, right? It just creates like a new instance, right? So if you want to retain values, if you want to retain variables, if you want to retain instances, right, and you want just one source of truth, a singular source of truth, using the singleton pattern is a very, very good approach. Yeah, majorly that is it. So I don't know if anyone has a question as regards to this. So I know you might have seen this even in shared preference class. Of course, this is exactly where I kind of like took this idea from. The only thing is I did not just copy the shared preferences class here. I kind of like just mimicked it so that I am sure I'm explaining properly. So yeah. Does anyone have any question as regards singleton before we move to the next one? Yeah, does anyone have? So factory dot internal, right, is a private constructor. So when you want to create a constructor, right, when you want to create, there are different kind of constructors you can create in a class in that, right? You can create shared preference manager. This is a constructor. This is a constructor. This is another constructor. This is another constructor, right? This is another constructor. This is another constructor, internal. This is another constructor. This is another constructor. This is another constructor. But the thing with this is a private constructor, right? Well, how this might still be accessible for some reasons, and that, yeah, it's accessible. So, well, how this might still be accessible for some reasons, best known to that, right? It is how we represent private constructors, right? So, say you don't want a constructor. So these are public constructors. These two are public constructors, right? They're public constructors. Say you don't want a constructor to be public, right? The way we represent it is with underscore, like you know already, in that underscores represent private constructors, right? So what I did here was just creating a private constructor that I am accessing. Does that make sense? Does anyone have any question? Again, so,
Yeah, can you hear me?
yeah, I can hear you.
So my own question is, in the factory constructor, you said return instance if it is not labeled. If it is not rather return a new instance.
Yeah.
Right. So why then are we not expecting a not label inside the middle? Since at every point in time there must always be an instance of shared preference manager. Why are we not?
There will not always be an instance of shared preference manager, right? Because firstly, when except you call this method, that's when you initialize it. But if for any reason, the user misses initialization, right, and just calls this. So like, some users are very, very stubborn, like me, right? The fact that I can create like a constructor, the fact that I can create like, I can create an instance. I can say final shared preferences manager equals to shared preferences manager. Without doing this shenanigans that we did, right? Where we did shared preference manager dot instance dot init or something, right, at the beginning of the. Let's say I do this, right? The point of a singleton is for no matter the instance you are, let's say no matter the instance you're calling, right? Let's say you're doing this or you are calling shared preferences dot instance. It should only take the instance defined here. So what factory does is a factory kind of like just builds your constructor based on, maybe we'll get factory in a bit, right? It builds your constructor based on maybe some checks, right? So let's say you call this, right? What we want to do is, if the instance here is null, right, we should set it to this constructor if the instance is null. So if it's non-null, then we can use the already existing instance. So let's say the user did not call this, right, and is just going ahead to create this. Whether the user likes it or not, right? So what the user is getting is still this one we've created. I don't know if you understand.
Yeah, I'm with you.
Yeah, so whether the user likes it or not, it's still this one we created here, and not manufacturing a new like instance of the class. So the idea of singleton is just one instance all through the life cycle of your software, right? One instance all through the life cycle of your software on create. Once you initialize it, well, let's say you are doing this, right? Let's say you are doing this. Once you create this instance, right, there's a factory constructor here that constructs the instance for you. So if this is non-nullable, right, we use it. If this is not null, we use it. But if it's null, right, we are setting it to this and then using it. Do you understand? So we are setting it to this and then using it. So that's the reason why we're checking if it's null or not null.
All right.
Yeah. So I don't know if anyone has any question. So yeah, majorly. Anyways, we can move to factory method, right? Yeah. So I know that you might have seen this factory and maybe ask the question in your head, okay, fine. I think this is one of the things that I was finding like a bit tricky when I was looking at it in that when I first started that. But the thing is, if you read through design pattern wiki, it's just straightforward, right? But yeah, factory method kind of like defines an interface um for creating like an object, but in this particular style, kind of like lets subclasses decide which class to instantiate, right? So more like it's kind of like promote loose coupling, right? So uh kind of like a way to eliminate the need um to bind application specific classes into code, something around that. But I would give you like an example to help you understand. So I'm not just saying gibberish, right? So we gave this is a very, very good example, but I will not use this because this is much more targeted at singleton than factory. So what I should have done is I should have styled factory and then come into singleton where anyone wants factory dot that. So let's say we have a class that could be an abstract class. Button, very, very good example for this. Um, uh, so I'm sorry we have to always imitate Flutter implementations, right? But yeah, abstract class button, let's imitate elevated button. So imitate elevator button. So kind of like implements button. Uh, Now I'm complicating everything. Okay, struct class widget. So button implements widgets. Elevated button implements widgets. What am I doing? Okay. So what we can do is we can just change this one to implementation, right? And just call this elevated button. Elevated button. Just call this elevated button. So yeah. So we have elevated button implementation. We should need a text button implementation too. So return this is elevated button, return elevated button. So we should have a button implementation. Just trying to use an example that we might all be familiar with, but I think I'm creating a problem for myself. Yeah. Create one mixing override. return text button. So abstract class text button, blah blah blah. So let's say we have a factory, a button factory, right? Factory. Let's say we have a button factory.
Sorry to interrupt. The username and just wrote the new one.
So we have a button factory. Has everyone joined? I believe. Okay. So we have a button factory, right? So let's say we have a factory, button factory. So for this button factory, we want it to take like a button type, string type. So it can be, but we can't exactly with this idea. Anyways, it's still the same concept, right? It's still the same concept. With this idea, it's not a type of button factory, so it's not going to work except we make the factory function inside. Anyways, it's the same idea. I will just use a static class instead, right? So we have a static button, create button. So we can have a button type. So yeah, so based on the type, so let's say we have a switch function. Based on the type, you can decide what to use. So let's say there's a case, elevated. I could have used an number. I don't know, trying not to complicate what I already complicated. But yeah, we could have used an enum for this type. Well, it's not even enum, so it shouldn't be that button type and just elevated, weighted, and text button type. So what we can do is what implements button. So if it's elevated, this button type dot elevated return elevated button. Implementation case dot text return text button implementation. Right, so this is majorly what factory does, right? So it lets the subclass. You definitely would have used it a lot of time, right? It lets your subclass decide, which of the classes to instantiate. Say you have multiple classes. Say you have multiple types of button, right? And you don't want to start doing like some checks on your front end, right, or on your UI rather. You don't want to start doing some checks on your UI. What you might want to do is just use kind of like this pattern, and all you just need to do is pass the type so it knows what button type. This can be used in numerous scenarios, right? So this one is like still very, very simplistic. So let's say you have a very, very complicated system. This will help you not do like a lot of checks on your front end, right? So let's say you have types, different types of classes, right? It's very, very easy for you to just do checks from here. So majorly that is it on factory pattern. So the next class we might talk about abstract factory, and then we can move into structural. Yeah, deals with like creating relationships to form kind of like larger structures, but I don't want to. I think the class would get very, very long, and because of the video, right, I'm trying as much as possible to not to make it exceed 1 hour. And I don't know why it's freezing here, but yeah, I'm trying as much as possible not to make it exceed 1 hour. So yes, that should be it for today. Next class we can talk about, but it's not going to be tomorrow. It can be Saturday, right? We can talk about abstract factory, and then look into structural patterns, and then after structural patterns we look at behavioral patterns, right? Yeah, after behavioral we can now look at architectures, um what they are, and yeah. So I believe that should be it. Does anyone have any question any question before we round up? So we've spoken about what design patterns are, what architectures are, um, what makes up an architecture. We talked about system structure, component relationship properties, and which the properties would allow you to make design decisions. So what are the properties of your architecture? Is it for security? Is it for performance? Is it for maintainability? Is it for scalability? Uh, scalability, blah blah blah. But yeah, I believe you guys get the context already. So does anyone have any question? All right. In that case, I don't know if Mercia has anything to say. So this is exactly 1 hour. I don't know if Mercia has anything to say. Then is I don't know if there's a way we can always have summaries, right? Summaries after the classes, maybe kind of like to kind of like a point of reference, right? Um, for these classes, if that's possible, that's fine, right? That would be awesome. So that can also have served kind of like as a description for the YouTube video. So in case you just want to remember something in the class, right? You don't have to jump through an hour video. But yeah, it's also great to check it back anyways. But yeah, that should be it from my hand.